Good afternoon. Hope that looks clear to you. We are going to do another example of a differential equation solving because you may see this, you may not, but there's a good chance that you will see it on the AP test. So let's do one. And this came from the 2013 test. I liked it because it had e to the y in there, some different things that we hadn't maybe seen before. So thought it was a good example. All right, so here's our differential equation, dy over dx. And it says, okay, let y equal f of x be our particular solution to the differential equation that passes through 1, 0. So they're giving us that initial condition. Okay, and then part A, let's focus on part A. Write an equation for the line tangent. And immediately you go to your flashcards again and go, oh, equation of a line tangent, I know that. What do I need for an equation of a line tangent? You said it, point and a slope. Okay, and they said the point is 1, 0. Well, shoot, we don't have to do any work for that. And the slope is dy over dx, exactly. So dy over dx is equal to e to the y, and this is our y, right? And this is our x. So e to the y, e to the 0, times 3x squared is 1 squared minus 6 times the 1. So pretty easy calculations. E to the 0 is 1. Yeah, you got that. And 3 minus 6 is negative 3. Okay, so then we write our equation is y minus y1 x minus x1, right? You remember that. And we just plug everything in. So y minus 0 is equal to negative 3x minus 1. And we can simplify this a little bit, negative 3x plus 3 if you want. Okay, and now we're going to use the tangent line to approximate f of 1.2. Okay, so f of 1.2, we just plug in 1.2 plus 3. So 3 times 2 is 6, right? And 3 times 1 is 3. So we get negative 3.6 plus 3. And we get negative 0.6. And that would be our answer for part A. Okay. All right, now part B is the fun part, right? Okay, part B here. Find y equals f of x, that particular solution. And they're giving us that xy. Okay, so part B. What's our first step? Particular solution. You got it. Separate the variables, right? Separate. And then integrate. So those are our steps. Right, so we're going to separate the variables. So I'm going to have dy, going to divide by e to the y, right? Divide both sides by e to the y. And we're going to leave this here, right? And multiply by dx. Okay, so we get e to the negative y is equal to 3x squared minus 6x dx. And then our second step, so that was step 1, is to antiderive. E to the negative y dy is equal to the integral 3x minus 6x dx. Okay. Oh, and I'm almost off the page here. Here we go. I'm going to move us all the way up. Okay. So we want to antiderive. What happens to e to the x when we take the derivative or the antiderivative? Yeah, you got it. Nothing, right? So it just stays e to the negative y. Now, we have to, if we're deriving, we would multiply by the chain. We're anti-deriving, so we're going to divide, and the derivative here is just negative 1. Okay, it's equal to, and this would be x cubed, right, minus x squared. That would be 3x squared, wouldn't it, plus c. Check my work there. Did I do that right? If I take the derivative, I should get that. Looks right to me. Okay, so we've got this here. I think I'm going to just clean this up just a little bit. So it's going to be negative 1 over e to the y is equal to x cubed minus 3x squared plus c. Let's go ahead and plug in our point, which was 1, 0, right? So this is our x and this is our y. So we get negative 1 e to the 0 is equal to 1 cubed minus 3 times 1 squared plus c. All right, so we get negative 1 here is equal to 1 minus 3 plus c. So negative 2 plus c, negative 1, we add the 2 over. I got c is equal to a positive 1. So hopefully that's correct. Now I'm going to go back to this general solution here and plug in my c value. So I've got negative 1 over e to the y is equal to x cubed minus 3x squared plus 1. Now, remember we can just flip everything here. Well, let's multiply through by a negative. So we get 1 over e to the y is equal to negative x cubed plus 3x squared minus 1. And now we can flip it. So e to the y is equal to 1 over this whole thing, negative x cubed plus 3x squared minus 1. And then if we want to get rid of e, what do? Yeah, you're right, we ln it. So this is going to look really bizarre. So ln of e to the y is equal to ln of this whole thing, 1 over negative x cubed plus 3x squared minus 1. Okay, so y is equal to the ln of 1 over negative x cubed plus 3x squared minus 1. And I think that should probably be in absolute values, so I'm gonna go with that.